All right, y'all, I'm gonna try something new. Oh, this is gonna be a bad idea. Hi, Corduroy. I love you. Let's go outside. Come on. Yeah. It's only 90 degrees out. You're gonna love it. I'll be right back with you. He has water, I promise. All right, so we're gonna talk about that one challenge question I gave you. There were 3 different options, and I asked which has the better or stronger bond. The first option I believe I gave you was methanol, which is CH4O. So in order to determine which has a stronger bond, remember there's 2 things that are determined which have a higher bond strength when we're talking about molecules or things with 2 or more nonmetals. Those things that we're talking about are the bond order and size. What we'll eventually realize is because we're talking about CO bonds, the size isn't going to be any different because carbon is going to be the same size and oxygen is going to be the same size. So that's not going to be the issue. The question is going to be bond order, which is going to tell us which one's stronger depending on if it's single, double, triple, etc. bonds. All right, so let's go ahead and look at this. Get this out of the way here. Let's start with the methanol. That was our first choice. CH4O, we actually drew this in another video, but if you remember, hydrogen always has to go on the outside and carbon likes to make 4 bonds. So if we start by making carbon have 4 bonds, we know that oxygen has to go between one of these things in order to make a hydrogen on the outside. Again, we did this earlier. You'd want to count valence electrons though. Here we have 4 from the carbon, plus 4 times 1 from the hydrogen, plus 6 for the oxygen, gives me a total of 14 bonds. Or excuse me, 14 electrons. So as we go through here, let's go ahead and count what we've got so far. We've got 2, 4, 6, 8, 10. That's cool because oxygen doesn't have an octet. Carbon does. Hydrogens don't need octets, but this oxygen needs an octet, so we put 4 electrons on there. And in fact, you'll find that oxygen loves to have 2 bonds and 4 electrons on it. And this is what we have. So in comparing this is a carbon, oxygen, this is a single bond, so it has a bond order of 1. All right, B, let's go ahead and look at carbon dioxide. We also did this in another video. I'm gonna move this hydrogen up a little bit just so I have some more space. So carbon dioxide is CO2. As we draw it out, there should be 4 plus 2 times 6. So that's 12, that's 16 electrons. If we go through and draw carbon out, again, carbon likes to make 4 bonds, but there's only 2 oxygens. But that's okay, I just told you up here, oxygen likes 2 bonds and 4 dots on it. So if we add 2 bonds here, and you can go through and do it the longer way, which we discussed earlier, but you'll eventually again get to the fact that you see carbon, no it wants 4 bonds, oxygen, no it wants 2 bonds, and then fill in the octets. So we need 1, 2, 3, 4, and 1, 2, 3, 4. So here we're talking about a CO bond order of 2 because the carbon and oxygen have 2 bonds between them. Let's look at C. Carbon monoxide. Now this is a really fun one to do. Carbon monoxide is CO. Carbon likes 4 bonds, oxygen likes 2 bonds. We're screwed. There's no way that we can do anything that's going to make them both happy. And so all we can do is try to give them octets and then figure out how many valence electrons they have and then change the number of bonds to make sure that it matches. So let's look at this first, the number of valence electrons. Here we have 4 from the carbon plus 6 from the oxygen for a total of 10. So we need to have something that has 10 valence electrons. If we go through and add electrons to these to make sure that they have an octet, and then we go count these electrons, right now we have 2, 4, 6, 8, 10, 12, 14. Uh-oh, we got 14. If you remember, if we take away 2 of those and add a bond, that's going to take away 2 of the electrons that are in here. So now we should have 12, but let's count. 2, 4, 6, 8, 10, 12. Now we have to do it one more time. Take away another lone pair on each of those and add another bond. And now we have 2, 4, 6, 8, 10. Both of these have an octet. This is actually wholly unstable, but the bond order is 3. So the question was, which has a stronger bond? Well, remember that if you have something that's just holding, we kind of talked about it like Red Rover. If you have 2 people that are just holding single arms and you have somebody run through them, it's no problem, that person can break right through it. 2 bonds is a little bit stronger, but 3 bonds, having 3 things, is going to be super strong. And that is why C should be your answer. I miss you guys a lot. Bye.